Sometimes the smartest answer is, I don't know. A controlled reasoning agent for technical documentation. Lessons from a Capstone project. Hello there. My name is Leandro. I'm a chemical engineer by training, with over 2 decades working in the mining industry, most of it at the intersection of data, process modeling, and operations. Last year, I completed a master's in data science. It was hands-on, rigorous, and gave me a solid technical foundation. But as you probably know, this field moves fast, and staying current means never really stopping. That's how I ended up in a Gen AI intensive course, a focused week on prompting, embeddings, agents, and production workflows. At the end, we had to build something real, something that used what we'd learned. I thought about a few ideas, but kept returning to a simple question. How do language models behave when answering technical questions? Because in my experience, even good models tend to guess. They generalize too much, mix sources, and answer with full confidence, even when they shouldn't. That might be fine in everyday use. But in high-risk domains, like heavy industry, guessing isn't an option. So I shifted the goal. Instead of getting better answers, I wanted a system that only answered when it truly could. A system that grounds every response, that doesn't guess, and that sees ambiguity as a reason to stop. That's how TAID was born, a technical assistant for industrial documentation, built to stay within clearly defined boundaries, even when backed by an open-ended model. None of this would have worked without Gemini. I used Gemini throughout the system, from document understanding to reasoning and final generation. And what stood out most was how simple it was to integrate. The function calling API made it easy to define a schema and extract structured information from each manual. It didn't feel like I had to fight the model into behaving. I just gave it clear instructions, and it delivered. In fact, the only tricky part was dealing with the raw data types returned by Gemini. Some responses come back as protobuf objects, and converting those to native Python structures took a bit of finesse. It's not complex once you get it, but it can be deceptively confusing the first time you hit that wall. Other than that, the process was smooth. Building the document catalog was straightforward. I passed the full text of each PDF along with a prompt and schema, and Gemini returned clean, structured metadata. The type of document, the manufacturer, the model, a summary, and key technical terms. That catalog became the foundation. When a user asks a question, the system uses Gemini again to evaluate which document is the best match. And if no match is strong enough, it stops. No fallback logic, no speculation. Only when the right document is found does the system move to retrieval. It pulls the relevant fragments, calculates similarity, and feeds them to Gemini one last time, this time to generate a structured fact sheet with the answer, any warnings, the logic behind the response, and references to the original sections. Each prompt had a single task. Each step was controlled. And that's what made Gemini so valuable. It respected those boundaries. To test it, I used a data set of real manuals from the construction industry. And it worked. TAID handled real questions about maintenance schedules, tension adjustment, and cold weather precautions. But the most important behavior? It refused to answer when it shouldn't. Ask about something outside the data set, and it simply says, "No suitable document found." That's not failure. That's design. This wasn't about building a system that's always right. It was about building one that knows when not to speak. Sometimes the smartest thing a model can say is, "I don't know." And sometimes that's exactly what we need.